Okay, so in the last class we discussed about the different type of hazards. Okay, so what are the different type of hazards? So that is a data hazard. Okay, data hazard due to the non-availability of the data, and also data dependency due to the data dependency. Then instruction hazard or control hazard. Instruction, or we can call it as control hazard. And third one is structural hazard. So these are the type of hazards that occur during the execution of an instruction. Okay, so the types of hazards, those are that is types of hazards. Data hazard. Data hazard, when it occurs due to the non-availability of source operand or destination operand. Okay, source or destination operand during the execution of an instruction. Some delay occur, and also due to the dependency. Then in the instruction hazard means due to the non-availability of the instruction during the while fetching the instruction, while fetching instructions. Okay, due to the non-availability of the instruction, so this instruction hazard will occur. Then means that because this program counter that will give the which instruction to be executed next. Okay, but here due to the some delay means the instruction is not available. Okay, due to the address calculation. Okay, because due to the label or due to the address calculation. Okay, so because of that, if the next instruction is not available, then instruction hazard or delay, the delay will occur. So in instruction hazard, if there is a specific in instruction hazard, okay, it is supposed to take one clock cycle, right? Here F2, but here still the instruction is not available. Okay, instruction is not available, so it is taking 3 extra clock cycle to execute the instruction, right? To execute the 3 extra clock, so that is called as, like, in the third clock cycle, you can see this instruction is fetching, means here the decoding unit is not doing anything. Okay, the decoding stage here, the same diagram is represented here. Okay, in this particular, this decode unit, okay, in the third clock cycle, you can see here it is idle stage, means uh, the first instruction is in the decoding stage. Okay, then in the second clock cycle, second instruction is fetched, but in the third cycle again it is fetching only, it is not going to the next stage because it is still the fetch of the instruction is not completed, so it cannot go to the decoding. So decoding जो unit है, this particular stage is there, no, it is idle means it is not doing any work, any task. In the fourth clock cycle also, you can see in the fourth clock cycle this is idle, क्योंकि it D2, because the second instruction has to go, but the instruction is not fetched. So in the clock cycle 5 also it is in the idle stage, but in the clock cycle C, the instruction here, at the end of the clock cycle 5, the fetching is completed, the F2 instruction is completed, then it is going to the decoding stage. Okay, it is going to the decoding stage. Okay, So this will also reflect to the other stages. Okay, next instructions, because yeah, in the third clock cycle decoding is idle. In the fourth clock cycle decoding unit and execution unit both are idle, means it is not, because instruction is not executing, उसको कुछ input ही नहीं मिल रहा है, it is not getting any input. Okay, and here in the fifth cycle decoding, execution and write, these खाली है, but it is still fetching, and here at the end of the clock cycle 5 it is completing the instruction execution. Okay, so this particular जो ये this particular period, that is means it is not doing any work, so that is called as idle periods. This is called as idle periods or stalls. We call it as stalls. That comes only in instruction hazard. Instruction hazard only we will get that. If suppose if any stage, if any stage is not performing any task, not performing any task, so that is called as idle period. Structural hazard means if there are two instructions that requires to use this given hardware resource at the same time. Okay, in the last class we discussed with the memory instruction, memory memory unit. Okay, means two instructions are there, two instructions they want to use the same memory. Okay, to like fetch the instruction from a memory or to load the data to the memory, so some delays occur. Okay, so that is the structural hazard. So here the pipelining does not result in the individual instruction being executed faster. Okay, so pipelining means it affects the throughput. The throughput increases. The time required for the individual instruction, the time required for individual instruction is same. Time required for individual instruction execution. Time required for individual instruction execution is same. Okay, but here the throughput increases. Okay, the throughput is measured by the rate at which instruction being execution is completed. Pipeline stall causes the degradation in the pipeline performance. Pipeline stall means like idle period. That idle period, or due to the data dependency. Okay, that is a delay, right? So all these stall that causes the degradation in the pipeline performance. क्या होता है? Delay होता है. Okay, like as a normal example, generally if I suppose if my class is at 10 a.m. okay, so you are having the classes like 9 to 9:50, 10 to 10:50, 11 to 11:50, 12 to 12:50. This is your stages. This is your one stage, second stage, third stage, fourth stage. Okay, so this is this particular stage is this it took same 50-minute time. It is executed successfully. Okay, then here suppose if there is a delay, if the class started in the 10:20, okay, and it is taking 50 minutes time, the class time is 50 minutes, तो क्या होता है यहाँ, it will complete in the 11:10, है ना? तो क्या होता है यहाँ, it will इफेक्ट टू द नेक्स्ट स्टेज मीन्स और डिले होता है। अभी ये और एक 10 मिनट गैप सपोज दे के लिया तो 11:20 टू 12:10 मीन्स द थ्रूपुट आपका क्या होता है, it will affect to the other stages, so that degrade the performance, okay, and the time required for each class is same, ये जो 50 minutes है ना same है, okay, 50 minutes is same, but if there is some delay occurs, okay, due to the some any hardware problem, like suppose if my laptop is not working properly or some power problem, some any problem, and if I start late, it will affect the performance. Okay, so this is about all we discussed about like with the laundry example, how we can improve the throughput. Okay, in sequential process. Okay, in a sequential process, that laundry example. Okay, so to complete the 4 load. Okay, each load takes the कितना 90 minutes time ना to complete. तो वैसे 4 लोड है हमारे पास. 4 लोड मीन्स one load is equivalent to 1 hour 30 minute. Okay, 1 hour 30 minute. So 4 loads are there, it is taking the 6 hours to complete. So this is using the sequential process. Then in pipeline we are getting around 3 and 3 or 30 minutes, I think. Okay, in pipeline process, means we are utilizing the resources parallelly. Like in this particular time, we are using these resources, all resources at a time. Like the A load is folding stage, B load in drying machine, and the third load is in the washing machine. Means we are utilizing the resources, and we are not affecting the time required is same, but we are utilizing the hardware resources. That will same applicable to the computer instruction execution. But there are some problem occurs, and that problem is called as hazards. Okay, so next we will discuss there are some types of pipeline. There are two type of pipeline. One is linear pipeline and non-linear pipeline. So there are two type of pipelines: linear and non-linear. Non-linear pipeline. These are the two types. So what is linear pipeline? Okay, a linear pipeline processor is a cascade of processing stages. Stages means like now we discussed 4-stage pipeline, 2-stage pipeline, and all in the last class. So it is a cascade of pipeline stages which are linearly connected to form a fixed function over the stream of data flowing from one end to other. So depending on the control of data flow along the pipeline, we model the linear pipeline into two types. Okay, see, linear means क्या होता है, the pipelines are cascaded one by one. Okay, it like a water flow pipeline, how the pipeline that connects. Okay, this is one pipeline and it is connected to another pipeline. Okay, here some water is flowing. Okay, but in that there are depend upon the data flow, control of data flow along the pipeline, we model linear pipeline is again into two types, that is asynchronous and synchronous. You know what is a synchronous, like a synchronous counter, you know. Okay, synchronous counter circuits means, you know what is synchronous means, it is with respect to clock. With respect to clock it will affect, means at a time, okay, synchronous. So linear means cascade of processing stages. A linear pipeline processor is constructed with k stages. K stages, processing stage. The inputs are fed to the pipeline at the first stage S1. The The processed results are passed from stage I to stage I plus 1 for I is equal to 1, 2, 3, k minus 1, and the last stage is sk. So here the diagram, okay, so here this is the asynchronous model, okay, asynchronous model of pipeline linear asynchronous model of linear pipeline. So this asynchronous here the data flow, see here these are the stages. This is one stage, this is the second stage. Likewise there are k number of stages are connected, okay. So here in asynchronous model the data flow between adjacent stages, adjacent means this S1 is adjacent to S2 stage, okay. In an asynchronous pipeline is controlled by handshake protocol. You know what is handshake protocol? Handshake means if A want to send the signal to B, then he will check whether the B is ready or not, okay. Once the B is ready, A sends the data to B and it will send an acknowledgement like I have received the data. Handshake signal, okay. So asynchronous model that uses the handshaking protocol, when stage Si this is ready to transmit, it sends a ready signal to stage, that is next stage. Then after the stage Si plus 1 receives the incoming data, it returns an acknowledgement to the Si, okay. So here in this linear pipeline asynchronous में क्या होता है, this is S1, this is S2, this is S3 stages, okay, like k number of stages, okay. So if S1 want to send a message like the data, S1 means you can consider like it is instruction fetch, instruction decode, execution unit. Like if S1 transmit the data to S1, then it sends in a ready signal like I'm ready to transmit, okay. Ready signal to S2, then it transmits the data. Then after transmitting the data, S2 if it once it receives, it sends an acknowledgement like I have received your data. Likewise S2 sends a ready signal to S3, okay. Once it transmits the data, it will send an acknowledgement. तो ये किस में हो गया है, दिस इज asynchronous mode, okay. Asynchronous में when stage S1 is ready to transmit, it sends ready signal to the next stage. Then once the Si plus 1, that is S2 receives the data, it sends an acknowledgement to previous. Asynchronous pipelines are useful, so these are useful in designing communication channels in message passing multi-computers where pipeline wormhole routing is practiced. So asynchronous pipeline may have variable throughput rate. Throughput rate is variable, okay. So different amounts of delay may be experienced at different stage, okay. Here we can get different delay, means here like here S1 is sending a ready signal to S2, okay. Then it transmits the data to S2. Once this data S2 receives, it sends an acknowledgement. Here the different amount of delay will occur at different stage, because here there is a ready signal acknowledgement, this is some communication is happening, the handshaking communication. So यहाँ क्या हो जाता है, at every stage, because here the it is depend upon the instruction, we'll get a delay delay at different stage, तो अलग अलग ये मिल जाता है different stage. So in synchronous model, what happens? Synchronous, where clocked latches are used to interface between the latch, means it is a buffer. Okay, latch, here this is S1 stage, okay, S2 stage, and S2, S3 and all, okay, and between each stage, like we are keeping a latch circuit. We are keeping a latch circuit between the stages. Latch circuit between the stages. Okay. Okay. Latch means it is open close, like master slave flip flop, sometimes on off, which can isolate input from the output. Upon arriving the clock pulse, all the latches transfer the data to next stage simultaneously. Okay, clock once we provide the input to the latch circuit, okay, this will activate, and at a time it transfers the data to the next stage. Okay, so this, see here what happens. So this is the stage S1, means one stage, one like instruction fetch or instruction, like, okay. So if I explain with the general example, okay, suppose this is a pipe, okay, like what to flow the water, okay, to flow the water, and here one small door, okay, means to there is a connection is there here, and there is a connection, okay. S1, S2, S3, this is a latch circuit, and this will activate with respect to the clock. Okay. So here the input and here output. So here what happens, this is connected, S1, S2, S3, okay. So stages, so like for example what happens here, uh, this particular stage S1 to S2, okay, it transfers the data, okay. When it transfers, when this particular latch, when it activates, okay, so at a time the clock pulse, means if we on the clock, okay, it is a synchronous means at a time this latch, both latch 1 and latch 2, they activate, and S1 data will transfer to S2, and whatever the previous data is there, data will transfer to S3, means it will open. If you just imagine with a water flow, this is a water pipe 1, and this is the water pipe 2, and here it is closed, here it is closed is there, here it is closed, okay, here it is, there is a close, here also some close is there, okay. So suppose if the water, the pump man, if he open the door. Open the door means if he transport the water through pipe, so he will open the gate, like gate means the door. Once you open, at a time this will open, this also, and this both the latch will open. So whatever the amount of water is there here, this will data transfer to this and this to this. Means at a time it will transfer. At a time it will transfer. But it will pass through water, whatever water is there, no, it is passed through this latch circuit. Latch is a temporary storage. Latch, or we also call it as buffer. Latch circuit, or it is also called a buffer. We can call it as a buffer. Okay. Means here suppose A person is there, B person is there, C person is there. Okay. Once this particular door will open, so A will come to B, B will come to C here at a time, at the same amount of time. That is synchronous clock cycle. Synchronous clock cycle. In asynchronous, what happened? Asynchronous में क्या था? Asynchronous where the different delay will occur between the stage 1 and the stage 2. Between stage 1 and, because here handshaking protocol is used. Once the S1 is ready to transmit the data to S2, it sends a ready signal. Then after that it transfers the input. Okay, then it will send an acknowledgement कि I have received the data. So it is doing with all the stages. So there will be different delay will occur at different stages. Here the stage means what? The instruction fetch, instruction decode, execute. So these are the instruction execute. These are stages, different stages. Okay, in synchronous, these are the stages: S1, S2, here one more, S3 if you consider. And between the stages there is a latch circuit. Between the stages there is a latch circuit. Okay, and once we trigger this clock, trigger at a time latch will open, latch will activate, and this data will transfer to the here S2, S2 का S3 में जाता है, S3 का S4 में जाता है. At a time it will perform. That is a synchronous pipeline. Synchronous pipeline. Clocked latches. Okay, synchronous means at a time. Okay, you know, like synchronous counter circuits. Synchronous counter. Okay, synchronous flip 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 flops. You know the flip flops circuits. On off, like with respect to the clock. Okay, synchronous counter means suppose in the lightings and all, suppose if there's a connection of light connection, so first two will on, then off, on, on, off, on, like how we configure the wiring circuit, on off, like here two times it will be on, here off, on, off, that we can design. So in such a way the clock will activate the latch and it will transfer the data. So pipeline consists of the cascading of processing stages, cascading of various different processing stages. Okay, as we discussed in the two-stage pipeline, four-stage pipeline. So it depends, like k-stage pipeline in general. The stages are combinational circuits performing arithmetic logical operation over the data stream flowing through the pipe. The stages are separated by the high-speed interface latch. Okay, the each stage is separated by a latch. Means it is a temporary storage. And fast registers. This is called as a latch, and also it contains, and also It consists of fast registers for holding the intermediate results. Okay, for holding the, suppose this is your hall, so this is your dining room, and this is your kitchen. Okay, this is your entrance, main entrance, and this is your backside. आपका suppose if your home is in this way, particular in this structure, तो क्या होता है यहाँ, to reach the key आपको ऐसा आना पड़ेगा, पहले होम योर हॉल में आना पड़ेगा, हॉल के बाद एक ऐसे एक स्पेस है थोड़ा, और कैन कंसिडर एज ए डोर और सम स्पेस, वो क्रॉस करके डाइनिंग हॉल में आना पड़ेगा, इसके बाद आपको और एक क्रॉस करना पड़ेगा, देन किचन, वन बाय वन स्टेजेस. This is general example, but in in terms of computer, like the units phase stages means like instruction fetch क्या करता है, this is a circuit, so it will fetch the instruction, it will means the fetch the instruction based upon the address that we provide. Okay, and also it involves the latches, registers and all. So latches means it stores the intermediate results. So the information flows between the adjacent stages are under the control of common clock that is applied to all the latches simultaneously. The information flow that is controlled by a common clock. So this is the in synchronous pipeline, the utilization of stages means, suppose if there is here it is a four stage pipeline, S1, S2, S3, S4, timing clock 1, clock 2, clock 3, clock 4. Okay, once the clock is activated in the latch circuit, so what happens, S1 का data S2 में जाता है, S2 का S3, S3 का S4 at a time. So all these, S1 is also busy, S2 is also busy, means utilized, stages are utilized, because here all the stages, like if with respect to clock, okay, clock means at a time, okay, here information flow between adjacent stages are under the control of common clock. So this particular clock, if suppose ये clock means at a time it will come, one आया तो at least, okay, this will open, या जो भी इनपुट है S1 में जाता है, एट द सेम टाइम S1 का S2 में, S2 का S3 में, S3 का, ये एक ही टाइम पे होता है. ओके, सिंक्रोनस. ओके, जस्ट नाउ वी डिस्कस दिस, ये जो इलेक्ट्रिकल वायर है, सपोज ऑन ऑफ so this on off, this wire is there, no, ये एट ए टाइम होता है ना, इट इज़ नॉट द वे हाउ यू कॉन्फ़िगर. आप इसको एक बार ऑन किया तो एट ए टाइम इन वन पल्स ये ऑन रहता है, ये ऑन रहता है, ये ऑन रहता है, ये ऑफ रहता है. इन सेकेंड क्लॉक पल्स वी कैन सेट लाइक इसको ऑन और इसको ऑफ. ओके, that is with respect to clock. So a reservation table, this is the term that you should know. What is a reservation table? It will specify the successive stages in a synchronous pipeline, means how the stages, it is show how the status are utilized, because sometimes due to some delay and all, the stages are in the idle state. Okay, idle state, suppose if there is some delay, right? So reservation table, it will show the utilization pattern. Okay, like you how once you book your reservation, बस में reservation करने के वक्त क्या होता है, you can see these are some seats. Okay, these are some seats, and once it is booked, so you can like, these are the seats booked, you can see the status. Okay, utilization of the reservation of the bus, reservation of bus. तो इसमें कितना हो गया, कितने 6 + 3 9 है, 9 seats are there, 9 में कितने हो गए, 1 4 5 seats are reserved. So in the same way here, with respect to reservation table, we can check which all stages are utilized. Okay, so reservation table represent the flow of data through the pipeline for one complete evaluation for a given function. So the mark entry ij that require the table indicates that stage Si will be used j time units. Means here stage Si means S1, S2, S3, S4. So that is busy with respect to the clock. Okay, x-axis or y-axis. Suppose if unique functional means if x mark indicates the unique functional application, means here E and B for two reservation table. So here this particular indicates, this particular x indicates it is busy, means it is utilized at this particular time. Okay, the same diagrams are there, I have taken from the textbook. Okay, so just keep in mind, so today we will discuss about linear pipeline, non-linear pipeline. Okay, in linear pipeline again asynchronous and synchronous pipeline. Synchronous where handshake protocol is used for communication, and in a synchronous latch circuit is used. Okay, the some other like techniques are there, we'll discuss in the next class. And also like go through